Okay, today we're going to talk about this particular question on function. So it's not exactly an easy question, but you could give it a try first. Okay, so let's get to it. Okay, so first of all, we are given some conditions, right? So f1 is equals to 1, and fx plus 5 is greater equals to fx plus 5. Okay, and then another one is f of x plus 1 is less than equals to f of x plus 1. Okay, so the function fx is such that x is the element of all real numbers. Okay, so after establishing the conditions, right, so let's look at how we can make use of the inequalities to help us to get to the answer. All right, so what we are trying to find is f of 2000 squared. Okay, so let's write down the inequalities. Okay, so first of all, we have f of x plus 1, and that is less than equals to f of x plus 1, right? So that is something that is given. So I can actually extend this to f of x plus 4 plus 1. So I'm replacing x with x plus 4. And then I will get this new inequality. Okay, so this is actually f of x plus 5. Okay, so I can say that f of x plus 5 is less than equals to f of x plus 4 and then plus 1. Okay, so now I can further extend the inequality to this. Okay, so this is less than equals to f of x plus 4 plus 1, which we have established earlier. Okay, and at the same time, it is also greater than f of x plus 5, right? Which is the initial condition that is given, right, on top. Okay, so the next step is to elaborate on this part, okay, the right-hand side of the inequality. Okay, so I'll do a side working here. Okay, so I can say that f of x plus 4 plus 1 is actually less than equals to f of x plus 3 plus 1 plus 1, right? The reason is because this is less than equals to this, right? So again, I'm using the initial conditions given, okay? Right, so this is the condition that I'm using. Okay, so let's expand this. So this becomes f of x plus 2 plus 1 plus 1 plus 1, right? If you notice the pattern, and then I can continue. And this will be f of x plus 1 plus 1 plus 1 plus 1 plus 1, right? So by now, I think you should be able to see the pattern, right? Which is less than equals to f of x plus 5, okay? So that's quite important, right? Because we just realized that f of x plus 4 plus 1 is less than equals to f of x plus 5. Okay, so I'm going to write the inequality again. Okay, so this becomes f of x plus 5 less than equals to f of x plus 5, and then less than equals to f of x plus 5, right? Because this is less than equals to this, right? So that's why I have this inequality now. Okay, so this is important because that tells us something, right? It tells us that f of x plus 5 is in fact f of x plus 5. Okay, so let's extend this. This would be f of, say, f of 6, right? That would be equals to f of 1 plus 5, right? So if you remember the initial condition, f of 1 is equals to 1, right? Which is 1 plus 5. So f of 6 is equals to 6. Okay, so let's try f of 7, right? So f of 7 will be f of 2 plus 5, right? And f of 2 is actually 2, so that's 2 plus 5, which is 7. So you can see where this is heading, right? So f of 6 is 6, f of 7 is 7. Okay, so f of 2000, right? F of 2000 will just be 2000. Okay, and the square of that is simply 2000 squared. Okay, so that's our answer. Okay, so hope you enjoyed the video. I'll see you next time.